Hi and welcome to my first video on vectors. Alright, now this video, these series of videos are going to be divided up into two sections. Vectors will come in the normal maths paper, and of course some slightly harder stuff will come in the additional mathematics paper. So I believe this is going to be two videos. For persons doing maths only will only need to watch video 1. For those who are doing admaths, you will need to watch video 1 as well as video 2. Alright, so let's get started on vectors for the maths, for the easy stuff, the maths syllabus. So let's first start off with what is a vector. Now I know some of you all are accustomed with this formula. The vector AB is equal to AO minus OB. I will not be using this formula. I have a totally different technique for explaining vectors. Right, so back to what is a vector. Let's say I have a straight line. It's just a line, right? So if the line has two ends, A and B, is the line going from A to B, or is it going from B to A? You don't know. Why? Because what is missing? A arrow is missing. So if I were to put an arrow, there would be no confusion as to where this line is starting and where this line is finishing. It's starting at A and it's finishing at B. So a vector, for the time being, I want you to imagine it like this. It's a line with an arrow. The arrow indicates the direction. So one other thing is missing, but I just want to show you how they will write it. If the line is starting at A and finishing at B, if it's going that way, you put AB and a little arrow on top. The arrow just represents the word vector. So I don't have to keep writing A vector AB. I can just put a little arrow on top. Okay? Right. Now one other thing is missing. The vector needs a value. So I am going to let you know what the value of the vector is. I am going to call it 4A minus 10B. So the value of this vector AB is 4A minus 10B. So a vector, to keep it simple, is a straight line with an arrow to indicate its direction, and it must also have a value. Alright, simple enough. Let's say that you are starting at A and you reach B, and now you want to return to A. If I am walking from B to A, please do not make the mistake and change the arrow around. The arrow always goes from the left to the right. Let's keep it simple. So if you are walking from B to A, you have to put B first and then A. And the arrow on top just represents the word vector. Vector A, B. The first letter is your starting point. The second letter is your finishing point, always. So the first letter is your start, and the last letter is where you will end up or finish. So what's the value from B to A? Now here's a real simple trick in vectors. If you are walking with the arrow and I give you the value, if you reverse direction and go against the arrow, whenever you are going against the arrow, you just have to look at the vector and make each piece the opposite. So anything like 4A right now is positive. The opposite of positive is negative. And the opposite of minus 10B is positive 10B. So what's the moral of the story here? Whenever you go the opposite direction or you are going against the arrow, you just have to make all the signs for each part of the vector the opposite. It's a really, really simple trick. And it saves a lot of time in the exam. So let me do another one quickly here for you all. Right? That simple trick will save you so much time in the exam. Let me just do a few one time so it sticks in your head. Let's say I have the vector PQ, and the value of this vector is minus 4m minus 10k. And I tell you the value of I forgot my arrow. So this is how they will write it. PQ is minus 4m minus 10k. So this means I'm walking from P to Q. But let's say I want to walk the opposite way from Q all the way to P. Well, anytime you're walking against the arrow, you just have to make all these signs the opposite. So negative, well, minus 4m becomes positive 4m, and minus 10k becomes positive 10k. You see what I did? I just made everyone the opposite. That's all you have to do. So if I have the vector LM, and I'm going from L to M, and I tell you the value of this vector is 2a. So the value of LM is 2a. So if I am planning to go the opposite direction from M to L, it will just be, well, right now it's positive 2a. Guess what? It will be negative 2a. Simple enough? All right. Let's do one more so it sticks in your head. Let me say I have the vector AB, and the value of AB is minus P. So AB is minus P. So if you are going the opposite way now, you're walking from B to A. The opposite of minus P is positive P. You can put the positive if you want, but if you don't put the positive, we both know it's positive. All right, so that's a little introduction to vectors there. Let's make it a little more complicated now, right? All right, let me draw one of the most popular type of questions here. Right. Let's draw a little situation here. We'll draw it big so I can write on it. I'm going to call here A. I'm going to call this point, O, A, and B. And I am going to tell you the value of OA is 3 common A minus B. And the value of OB is 5 minus 5A minus 2B. All right. So here's the question now. The examiner wants you to find this vector. He wants you to find the vector AB. So that's the aim of this question. Here's how you go about a question like this, right? These are given to you by the examiner, because I've had students ask me where these values came from. They came with the question. When you bought the question, it came with them. So if you are trying to find the vector AB, here's what I want you to do. I want you to take your ruler and draw a line from A all the way to B. Also, I want to find AB. So that means I'm starting at A, I'm finishing at B. Therefore, my arrow should be going from A to B. Anytime you draw a vector, figure out the direction of the arrow. So here's what you want to do. You want to imagine that each line here is a road. There are 3 roads. 1, 2, and 3. And you are standing at point A. So I'm going to draw a man standing at point A here. And you are trying to walk to point B. Now, the easiest way to walk from A to B is just to walk from A to B, right? You can just get up here and walk to B. But here's what you're going to do. You're going to pretend that this road AB is under construction. So nobody's allowed to walk on that road. So in other words, the easiest way to walk from one point to the next point, you're not allowed to walk that way. You're going to have to find a different way. So, how can you walk from A to B? Well, can't you walk from A to O and then O to B? I know this way is shorter. So it comes like you're taking a long cut, not a shortcut. So let's put down the plan for the examiner. We are going to walk from A to O. So we are going to walk from A to O. Then pretend the add sign represents the word then. When you reach O, you're going to walk from O to B. So that's your backup plan to walk from A to B, provided that this road is under construction. So A to O. What's the value of A to O? Well, I'm trying to trick you here. Because I gave you the value from O to A. You are going to walk from A to O. You are walking against the arrow. So what do you need to do with the signs? Anytime you walk against the arrow, you have to make all the signs the opposite. The opposite of positive 3A is minus 3A, and the opposite of minus B is positive B. Now, we are going to walk from O to B. When we are walking from O to B, you will notice we are walking with the arrow. We are not going against the arrow, we are going with the arrow. Anytime you are going with the arrow, right? This is the add sign here. When you're going with the arrow, you do not change the signs. You leave it as it is. So this will be minus 5A minus 2B. So we take this vector and add it to this vector. Now, when an addition and a subtraction touch, you ultimately get a minus. So let's just erase that. Okay? Right. A positive and a negative is a negative. So let's add up everyone and we'll finish with this question. Right? B is the same thing as 1B. So let's add up all the A's first. I always like to do everything in alphabetical order. It looks neater. Minus 3A minus 5A is minus 8A. 1B minus 2B is minus 1B. You can double check it on your calculator if you don't believe me. And this is the value of the vector AB. Now I want you to get into the habit of writing in your answer anytime you work it out. So the value of AB is minus 8 minus 1B. You see how I wrote it in on the diagram? I just didn't keep my answer here. Get in the habit of writing the answer on the paper, complete with the arrow. A vector is of no use unless you have the arrow, the direction. Alright, let's try a harder example. Oh, by the way, I just want to clear up a few things. Suppose the examiner asks you, right? Now I had asked you to find AB. Let's say in part B in the question, he had asked you to find BA. How is this question different from the first question? The first question asked you to find AB, which means you are standing at A and you are trying to walk to B. But if you are trying to find BA, that means the first letter is B. So that means you are now standing at B and you are trying to walk to A. So what would be your plan? To walk from B to O, and then when you reach O, walk from O to A. So let's put that plan for the examiner. Walk from B to O, B to O, then, that's the addition sign, walk from O to A. Alright, B to O. Are you going with the arrow or against the arrow? It seems to me we are going against the arrow. So we have to make everyone here the opposite. You will get positive 5A, positive 2B. And once we reach O, we are going to walk from O to A. Notice we are going with the arrow. So we do not need to change the signs. Positive 3A and minus 1B. If we add up all the A's, we will get positive 8A. And if we add up all the B's, 2B minus 1B is positive 1B. You notice I just wasted a lot of time for no reason to show you something. When I found AB, then the examiner asked me to find BA. But aren't AB and BA opposites? So if he had asked me to find BA, I'm walking against the arrow. All I needed to do was make each sign the opposite. Negative 8A became positive 8A, and negative 1B became positive 1B. All right. So let's do a harder question. So it's pretty simple. Let's go. Let's try one with 3 vectors. Okay. All right. Let's try O, P, Q, and R. Let's say the value of this vector is minus A. The value of this vector is, let me see, I want to make sure that when this goes here, all right, over here is 2A minus B, and this one is 4A, minus 3B. All right, let's try our first question. Let's say they ask us to find the vector QP. And then let's assume they ask us to find RQ. I'm not too sure, I need enough space to leave enough space for working. So let's try this one here. Let's find QP. QP means you are standing at Q and trying to walk to P. So this is Q, and you're trying to walk to P. So put the direction. That's the direction you're trying to walk. But this road, the easiest way to walk from Q to P is just to walk the red road, but pretend this road is under construction. So you need to find a backup plan. How else can you walk from Q to P? Well, you're standing at Q. You're going to walk from Q to O, and then O to P. Q to O, and then O to P. So let's plug in the values. QO, is that with the arrow or against the arrow? It's against the arrow. So I have to make everything here the opposite. The positive 2A becomes minus 2A, and the minus B becomes positive B. Right? When, put the plus sign here, that's this plus sign. When we go from Q to O, now it's time to walk from O to P. I am going with the arrow. I have to make no changes to the value the examiner gave me. So it's just minus A. So a positive and a negative will ultimately give me a negative. And you know this is minus 1A. So let's add up all these. Minus 2A minus 1A is minus 3A plus B. So over here, the value is minus 3A plus B. You see, I'm trying to develop a good habit here. As soon as I got the value for QP, Q to P with the arrow, going from Q to P, and I put the value over here. Get in the habit of doing it, even if the examiner didn't tell you to do it. This will help you out in the exam. Right, follow the division line there. Let's find RQ. That's the green line. You want to walk from R all the way to Q. So you're standing at R and you want to walk to Q. The easiest way to walk from R to Q is this dashed green line, but that road is under construction. How can you reach from R to Q? R to O, and then O to Q. You're going to walk, right? So you're going to walk from R to O. That's this way. Once you reach O, you're going to walk to Q. R to O, then O to Q. Alright, you notice for each step I'm doing, like when I put the 2 letters, I put in a little arrow on top. And please don't forget your arrows. RO, help me out. Is this with the arrow or against the arrow? That's against the arrow. So I have to make this sign the opposite. That is positive 3B. What about OQ? If I'm walking from O to Q, am I going with the arrow or against the arrow? I'm going with the arrow. I don't have to make any changes for OQ. So let's add up all the A's and all the B's. And only have one set of A, 2A, and add up all the B's. 3B minus 1B is positive 2B. So the value from R to Q is 2A plus 2B. I put the value on my diagram complete with my arrow. All right. So let me show you a magic trick now. Let's say we just found R to Q, right? Fair enough. So let's say someone wanted to find RQ and they did it a different way. Remember, I just went from R to O and O to Q. So let me just pretend that we don't know this answer here, right? Never mind this book. It's my son's book. All right. So let's, remember the answer is 2A plus 2B. Let's work it out a different way. Let me clear some more space. Let's say somebody else just entered the room and we tell them, hey, find RQ. And they decide to be very difficult. So instead of going from R to O and O to Q, they go from R to O, O to P, and then P to Q. They take a very long cut. Instead of using 1, 2 roads, they use 1, 2, 3 roads. Let's see what will happen. So let's play along with their game. R to O, then O to P, not a problem, that's what they want to do, and then P to Q. They probably have a lot of extra energy and decide to do some extra, they're probably exercising, who knows. Let's listen 3 different colors. R to O. Is this against the arrow or with the arrow? That's against the arrow. I'm running this way. So it will be positive 3B plus OP. OP is with the arrow. So that's minus A. I don't have to change anything. I'm going with the arrow. And then plus PQ. Remember, we got PQ from the question before. PQ, you notice I put my arrow. PQ, if you're running from P to Q, is against the arrow. I'm going against the arrow. So I definitely need to make everything there the opposite. Minus 3A becomes, positive 3A. And positive B becomes what? Minus B. So remember, a positive and a negative is really a negative. Let us clear that up one time. Let's add up all the A's. Minus A plus 3A minus 1A plus 3A is positive 2A. And 3B minus 1B is positive 2B. Voila! We got the same answer, even if we did it an extra long way. That's the magic of vectors. It doesn't matter how much roads you take. Once your starting point and your end point is the same. All right? Let's try. Oh, I just want to point out one thing. You notice, O, anytime you see O in vectors, it usually stands for the origin. You know, when you have a graph, you have an X and a Y axis, and it's called the center, the origin. This O represents the origin. And anytime a vector starts at O, there's a special name for it. You call it a position vector. So OP, the vector OP, because it starts at O it starts at O, you call this a position vector. OQ is also a position vector because it's connected to O. And OR is also a position vector because all these vectors start at O. However, PQ is not a position vector because PQ starts at P and goes to Q. Also, QR is not a position vector because it starts at Q and ends at R. It does not start at O. So I just wanted to clear that up because sometimes in the exam you hear the examiner use the term a position vector. And you're probably wondering, well, how come that? What's the difference between that and a normal vector? A position vector starts at O. The first point has to be the origin. And the reason I'm telling you that again is because sometimes in some vectors you need graph paper to do the question. So when you hear position vector, you know to connect it to the origin in the graph. I will be doing questions like that, so don't worry. All right, let's go here again. Okay, let's try it. Oh, okay. Let me put a vector here. Okay. Now, there are certain vectors you can draw on graph paper and certain vectors you cannot draw on graph paper. I've been using a lot of letters so far for the value of vectors. You've seen me use common A. I believe you see me, well, I use common A, I use common B, I believe. I'm not too sure if I use common P and common Q, right? I'm not talking about the capital letters, I'm talking about the letters with the arrows, right? There are two special letters that are used in vectors for CXC. I and common J. Anytime they use the letters common I and common J, you can actually draw this on graph paper, right? You don't have to draw it on graph paper. You can get out the question without drawing it on graph paper. But only I and J vectors, you can draw it on graph paper. A, B, like any other letters, do not draw it on graph paper. And anytime a letter has I and J, I'm going to keep reminding you that these two letters are special letters and they get special treatment in vector land, right? So let's try some questions with I and J in it. Let's say we have two vectors, OM and ON. And the value of OM is 2I minus 3J, special letters. And the value of ON is minus 5J. Great. So let's say they ask you to find the vector MN. So that's the first question. They want you to find that vector. So let's go ahead and find it. First things first with I and J. Now I told you there are special vectors. When it's I and J, there's two ways you can write it. You can write it horizontal like this, or you can write it in, well, let's call it the vertical way of writing it, but the real name is column form. It's 2 and minus 3. You notice when I write it vertical, there's no I and J. That is because the top number is automatically I and the underneath number is automatically J. But only reserve this special way for I and J, please. If I want to write this in special form, you notice this one here has an I and this one has a J. This one only has a J. That means the I value is automatically 0. So if I want to write this in vertical form or column form, it will be like this: 0 minus 5. The top is 0, that's the I value, and the J value is minus 5. Okay, just checking the time here on the, well, it's only 29 minutes. That's good. So let's find the vector Mn. M, and you want to walk all the way to N. Okay, I'm going to work this two ways. I'm going to be using the normal horizontal way, and then I'll show you how to use the vertical way. You're going to fall in love with the vertical method, the column vector method. All right, Mn. What's the how do you walk from M to N? M to O and O to N. That actually spells a word. M to O and then O to N. See that? M to O and then O to N. Spells moon. All right, that's really not amazing. Oy. All right, MO. Am I going with the arrow or against the arrow? I'm going against the arrow. So it will be minus 2i plus 3j. See, I made the signs the opposite. And on, I am going with the arrow. So it's 0i minus 5j. Let's add up all the i's and all the j's. These are the i's. Well, minus 2 plus 0 is minus 2i. And 3j minus 5j is minus 2j. So the value from m to n, I draw it in, I put my arrow and everything to indicate the direction, is minus 2i minus 2 what? J. Okay. Let's work it using the column form. Some people love this method. M to O. This is the value of OM. So M to O, we just have to make the signs the opposite. Positive 2 becomes negative 2. Negative 3 becomes positive 3. Plus ON. ON, remember the I value wasn't written, but if it's not written, it's automatically 0. And I has to come before the J. The i's go on top and the j's go underneath. So on is 0 minus 5. So to get the answer, add the two top numbers. Minus 2 plus 0 is minus 2. And 3 plus minus 5. Now a plus and a minus is a minus. So it's 3 minus 5, which is minus 2. The top is I, the underneath is j. It's the same exact answer. But see how neat this looks? But like I said, only reserve this for I and j. The special... Think of the I and j as the king and queen of vector land. They get special treatment. So let's give you another question now. Let's say I ask you to find OM, the vector OM, and I put two lines like this. Alright. Big question is, what do they mean? What do these two lines mean? These two lines mean magnitude. Right? Whenever they ask you to find the magnitude of a vector, they can write out the word or just use the symbol for it. If I wrote an exam, if I was setting an exam, I would use the symbol to test students on if they knew that this meant magnitude. So how do you find the magnitude of a vector, right? I'm going to write a little formula here. MAG is just magnitude. In fact, let me clear some space here. I have so much space here. Alright. How do you find the magnitude of a vector? Well, unfortunately, there's a big square root sign. In the square root sign, in brackets, I'm going to put I value squared plus j value squared. Close bracket squared. So to find the magnitude of a vector, you just have to take the I value squared and then the j value squared, add it and square root it. This is really a Pythagoras theorem in disguise. Now you notice the formula says I value and j value. This means you can only find the magnitude of a vector when it's I and j, not when it's common A and common B, not when it's common P and not common Q, or common N and common M. It only works for I and j. Keep repeating that over and over, right? So how do you find the magnitude of OM? Well, for OM, the I value is 2 and the j value is minus 3. You can see it here too. Here's the I value and here's the j value. So when you put it into the formula, you're just taking the numbers touching I. You're not actually putting the I inside. So the number touching I is 2. So you say 2 squared plus, I'm getting black ink here, j squared, what's the value of j? Minus 3. So in brackets, please put the minus 3 and then the squared outside. Just don't put it like that. Follow the formula exact. If my formula has brackets, please put it in brackets. And you square root last. Do not press that square root button first. So let's work this out. 2 squared is 4. Minus 3 squared is positive 9. When you square a negative number, you still get a positive. Don't forget the square root. 4 plus 9 is 13. The square root of 13 will not give you a pretty number on your calculator, so leave it as the square root of 13. Right? If this was 25, you could have square root of 25 to get 5, but square root of 13 doesn't give you, like I said, a pretty number. It gives you an irrational number, so leave it as a surd. Leave it as the square root of 13. Alright? So I just showed you how to find the magnitude of a vector. Alright. Alright. Give me a chance here. Let me see what else I can show you in vectors here. Oh, I'm going to show you how. Alright, so let's try some parallel vectors. I guess you all know what parallel means already. If you have two lines, I think you all know what parallel means. That the lines will go on forever and they don't really touch. Like for example, these two markers are parallel. Also, these three markers are parallel because they're going the same basic direction. So, how do you prove that vectors are parallel? There are actually two methods you can use. I actually have a preferred, well, there's not something as a preferred method. It all depends on the type of question you get. The two methods, one has advantage over the other, depending on the situation. So let's try an easy one first. Let's say that you have two vectors. Now, parallel vectors don't have to have the same length. They just have to be going the same direction. You notice one is short here and one is long. Let's say the value of this vector is 2p minus 10q. And I'm going to call this vector pq. Then I have another vector, ab, which is a little bit longer. And I am telling you the value of this vector is ap minus 40q. And I want you to prove that these two vectors are parallel. Well, the one way of doing this is using factorization. So before I actually move further, let me just refresh your memory on factorization. Let's say I have 2x minus 4y, and I ask you to factorize this. When you factorize this, I know some of you all can do this in the head. You're going to pull out the 2, and you will get x minus 2y. Some of you all have been doing so much factorization, you just do it quickly in your head, you don't think too much, and you arrive at the answer. So let me slow this down a bit, because sometimes the numbers are not easy like 2 and 4. So what does it mean to factorize? When you are factorized and you are using the term pull out, remember I said we're going to pull out 2. What does pull out 2 really mean? When you are pulling out 2 and you're trying to get it into brackets, because that's what factorization is. It means you're trying to put it back into brackets. When you pull out 2, it really means you are secretly visiting everyone and dividing it by 2. So whatever you decide to pull out, that is what you are dividing everyone by. So the 2 will cancel out with the 2 here. 2 will go into 4 2 times. So you get x minus 2y. But you probably did it so fast in your mind, you probably didn't even realize that you were actually dividing. So let's try a harder one now, a harder factorization question. Because some of these questions come with harder numbers. They even come with fractions. So let's say we have 3a minus 10b. If I give that to a student, they probably won't know what to pull out. Because like the 2 and the 4, you know 4 is a factor of 2. So it's really easy to figure out. When you are factorizing and you can't find a factor, here's my advice. Just look at the first item and ask yourself what number is touching it. Well, 3 seems to be touching it. So whatever is touching the first item, let's pull that out. That's my advice. That's the rule of thumb that I use. So if I'm pulling out 3 from both of them, that means I'm secretly visiting everyone and dividing it by 3. 3 into 3 will give me, with 3 will cancel out with the A. And 10 divided by 3. Well, that's not going to look pretty on a calculator if you divide it. So just leave it as 10 on 3. Alright, and that's my answer if I am asked to factorize this. Like if I'm forced to factorize this. So, let's try a next one. Suppose they give me a fraction to factorize, right? I've seen students being stumped by this. 2/5 P minus 10Q. What to do? Let's make it harder. Let's make it 3/8 Q. What would you do in a case like this if you were forced to factorize? And the reason I'm telling you that you're being forced to factorize is because in vectors, sometimes you get crazy numbers and you're going to have no choice but to factorize. So you're going to be forced into it. So let's get used to it now. You don't know what to pull out. So what did I just tell you? Look at the first item and ask yourself what touching it. 2/5. So let's pull out 2/5. I'm going to put 2/5 outside the brackets because that's what we plan to pull out. But whatever we are pulling out, we have to visit everyone here and divide it by that number. So we are already dividing everyone here secretly by 2/5. So 2/5 will cancel out the 2/5, leaving you with P. Let's see what happens here. I'm going to take this to the side here. I'm just going to put the minus sign. That's this minus sign. And I'm going to take 3/8 and divide it by, I'm going to write it like how we write it in primary school. 3/8 divided by 2/5. 3/8 divided by 2/5. So, in primary school, the divide will change to a multiply, and this will change to 5 on 2. So, what will we get here? Well, there's nothing that can cancel out here, so we are forced to multiply 3 and 5 to get 15, and 8 by 2 is 16. So when we divide this by this, we get 15 on 16Q. And that's my answer. We have just factorized that expression. So, let's prove these two vectors are parallel using factorization. So let me put PQ here and vector AB here. PQ is 2P minus 10Q and AB is 8P minus 40Q. Right now, the two vectors do not look the same. If they looked the same, your job would have been super easy. You could have just simply said the two vectors are parallel because they have the same exact value. But unfortunately for us, they don't look the same. So here's how you prove it. We are going to factorize both expressions. This one's easy to factorize, so we're going to pull out 2. If we pull out 2, that means we're visiting everybody and dividing it by 2. So we're going to get P minus 5Q. Easy enough. This one here, we're going to pull out 8. If we are pulling out 8, because that's the number touching the first letter, we're just going to visit everyone and divide them by 8. 8 and the 8 will cancel out. 40 divided by 8 is 5. You notice that after you factorize both expressions, if you block out the number outside the brackets, the number inside the brackets look exactly the same. Once you get them to look the same, then you can write a sentence. Hence, the two vectors are what? Parallel. But the items in the brackets need to look the same. Alright? So, there's another thing. There's another item that you can. There's something else. That you can learn from this. These two vectors are basically the same vector, right? And we just said they are parallel. But this one has a 2 and this one has an 8. So which vector you think is bigger? The one with the 2 or the one with the 8? It would be the one with the 8. And how much times is it bigger? It would be 4 times bigger, because 8 is 4 times bigger than 2. So not only did we learn that they are parallel, but this one is the longer one and it's 4 times longer than PQ. All right. You basically call that a geometric relationship. If they ask you for two geometric relationships, between these two vectors, you can say they are parallel, and AB is 4 times longer than PQ. Right? That should be a 2-mark question in the CXC exam. All right, so let's try a harder question. All right. Try not to shake the table here. All right. Let's say I have another 2 vectors here. I'm going to call it Km, and the value of this one is 4 minus 3, and the value of the other vector, I'm going to call it AB, is going to be minus 2, 3 on 2. I have to put my arrows. That's very, very important. I want you to prove that these 2 vectors are parallel. Well, to prove they are parallel, right? Remember, when you're writing the vertical form, the column form, the top is I and the underneath is J. The top is I and the underneath is J. So you could write it back like this, 4I minus 3J if you want. And this is minus 2I plus 3 on 2J. All we need to do is factorize him, and if they look the same in the brackets, then they are parallel. So let's pull out. You might know what to pull out here, but like I said, look at the first letter. What is touching it? 4. So let's pull out the 4. So I'm secretly dividing him by 4 and secretly dividing him by 4. I'm going to get 4 to cancel out with the 4 to give me 1I. I could just put I if I want. Minus 3/4 G. And that's 0.75. What to pull out here? Minus 2. So I'm going to secretly visit him and divide him by minus 2. You notice I'm divided by minus 2 because that's the number touching the first letter, minus 2. And I'm going to divide him by minus 2. Minus 2 divided by minus 2 will cancel out, so you just get I. Let's pull this aside. You have 3 on 2 divided by minus 2. Remember, minus 2 is the same thing as minus 2 on 1. So this is 3 on 2 divided by minus 2 on 1. The divide changes to a multiply and you flip it. So 3 multiplied by 1 is 3. 2 by minus 2 is minus 4. Well, it seems to me when you simplify this, you get minus 3/4 J. The 2 vectors look the same within the brackets. All right? So how do we interpret this? Which one do you think is the longer vector? This one has a 4 and this one has a minus 2. This one would be twice as long as this one because this has a 4 and minus 2. But this one has a minus sign, indicating that these two, how he is positive and he is negative, it means they are going opposite directions. So Km might look like this. Km is going this way and it's twice as long as AB. So AB is actually half of that. So I try to make it half this because this is supposed to be twice as long, but it's going the opposite direction. All right, so this is a more accurate representation of how the vectors would look. Right? Good. Now I want to show you the shortcut method of proving, the vectors are parallel. Okay? Let's say we have, I'm just neaten this up, then I'll start talking. Wait. If I wanted to prove these 2 vectors are parallel, all you really have to do is take the second value and divide it by the first value. Or take the first value and divide it by the second value. But I'm more accustomed to taking the second value and dividing it by the first value. That's just how I'm accustomed to. So for this one, the second value is minus 3 and the first value is 4. When I talk about the values, I'm talking about the numbers touching the letters. You're not actually putting the letters, just the number touching the letters. And for this one, if we take 3 on 2, the second value, and divide it by the first value, if you divide this, I bet you will get minus 3/4. You notice you get the same number? So that's another way of proving that they are parallel. You take the second value and divide it by the first value for both vectors. And if you get the same numbers, then they are parallel. But there's a disadvantage to the shortcut. When you do it this way, you can't tell which one is the longer vector and which one is the shorter vector. So I would only use this method if I'm in a rush, or I don't care which one is the longer one or which one is the shorter one. All right, so let's do another type of vector, another piece of theory on vectors. It's no longer parallel vectors. I am going to show you something called collinear points. Well, collinear. Alright, so this comes in vectors, is a very popular part of vectors. So I'm guessing I should explain what collinear means, right? So collinear just means a straight line. For example, if I have 3 points, A, B, and C. If I were to draw a line through all 3 points, they would form a perfect straight line. So I would say A, B, and C are collinear. So how do you prove 3 points are collinear? Well, ironically, it's really close. It's almost the same thing as parallel vectors. So that's why I showed you parallel vectors first. So let me show you how this question will come in the exam. And I need every bit of space on the board for this. So write down collinear, and it means a straight line. Okay, so I'm going to help you prove 3 points are in a straight line. All right, hope you're sipping on your coffee. All right, give me a little chance to draw this here. All right, so we have O, A, B, and C. I'm going to start off with 3 vectors. This vector is going to be, this is a hard question, by the way. So if you understand it, feel proud. Right? Notice I have my arrows, this going this way, that going this way, and I have 4A here. I want you to prove that these 3 points, A, B, and C, the green line, I want you to prove those 3 points are collinear, that they form a perfect straight line. How do you go about that? Really simple. If the examiner asks you to prove A, B, and C are collinear, that's the question, A, B, and C, I want you to write down the 3 points, A, B, and C, just like how I have it on the board. And here's what you're going to do. I want you to circle the first two letters. So the first 2 letters happen to be what? A and B. Right? Now, some people might mix up the letters. Let's say they put B, A, and C. Right? It doesn't matter if you mix up the letters. However you put down the letters, just circle the first 2 letters. But I have a knack for, I just have a thing for keeping everything in alphabetical order. So if it's A, B, and C, I'm not going to mix up the letters. So AB, circle the first 2 letters. Your job is to find the vector AB. Forget why you're finding it, I'm just telling you, find the first 2 letters, AB. So AB means you're standing at A and you want to walk to B. How can you walk from A to B? A to O and then O to B. So let's put on that plan. A to O and then O to B. Remember, when you're walking against the arrow, you change the signs. A to O, I'm going against the arrow, so that's minus 4A. And OB is with the arrow, so I'm not going to change a thing about that. So let's add up all the A's. Minus 4A plus 6A is positive 2A, and then you have a minus 3B. So the value of AB is 2A minus 3B. So let's put down that. AB is 2A minus 3B. Notice I updated my diagram. When you get an answer, please put it on the diagram. It will help you so much in the exam. Now, remember how we had circled the first two letters? We're going to circle the last two letters. It looks like a Venn diagram. Concentrate on the orange circle. What two letters are in the orange circle? BC. So let's find vector BC. BC, the easiest way to walk from B to C to me is from B to O and then O to C. So B to O and then O to C. B to O, are we going with the arrow or against the arrow? Against the arrow. So it's minus 6A plus 3B. I made all the signs the opposite. Plus OC. OC is with the arrow. I'm not going to change a thing. So 5 1/5 A minus 4/5 B. I put fractions in these questions on purpose to make it harder than it needs to be, just in case you get a really hard exam in the question in the exam. So let's add up all the A's and all the B's. Minus 6A plus 5 1/5 A. You can do that on your calculator using the fractions button. Minus 6 plus 5 1/5. Well, I should have been able to do that in my head, but get so dependent on the calculator. Minus 4/5 A. Let's add up all the B's. 3B minus 4/5 B. 3 minus 4/5. That's 2 1/5 B. All right. Now here's the thing. I really don't like mixed fractions. I have a phobia against them. Let's convert this to improper fraction one time. 2 by 5 is 10 plus 1 is 11. So it's 11 on 5B. So this BC, let's put the answer now. We just found BC is minus 4/5 A plus 11 on 5B. All right. So we have the two vectors. Let's just quickly recap what I did. When you have three vectors to prove that are 3 points to prove that they are collinear, write down the 3 points. Circle the first two, find that vector. Circle the last two, find that vector. And that's what we did. We found this vector and we found this vector. Now it's time to prove that they are collinear. So let me clean up the board here. I'll make it look a little bit neater. We're almost finished. Don't worry. Okay. AB is how much again? 2A minus 3B. And BC is minus 4/5 A plus 11 on 5B. Here's what we're going to do now. We're going to factorize AB and we're going to factorize BC, just like we did in parallel vectors. What are we going to pull out from the first one? We're going to pull out 2. When we pull out 2, we're secretly visiting every one and dividing them by 2. Well, you'll get A here because the 2 and the 2 will cancel out. And 3 divided by 2, if you want to put the 1.5. But 3 divided by 2 is 1.5. Or you can leave it as 3 on 2B. Whatever you want. This one here, and I use fractions on purpose, because you're not going to know what to pull out, right? So, you are going to pull out minus 4/5. Because that's the advice I gave you. Whatever is touching A, or the first letter, pull that out. So you are going to visit everyone individually and divide them by minus 4/5. Right. Well, this and this will obviously cancel out. The minus 4/5 and 4/5, bam, bam, to give you A. And you can type, well, a positive divided by a negative. Let's put the negative there one time. And on your calculator, well, actually we can do this. I'll do it the long way for you. 11 on 5 divided by 4/5. Remember, I took care of the signs already. A positive divided by a negative is a negative. The divide changes to what? A multiply, and you have to flip this. So you get 5 on 4. This and this will cancel out to give you 11 on 4. How much is 11 divided by 4? It's not. Lord, I think I did the wrong question. Ah, Lord. Alright, so when we divided, did I do anything wrong here? 11. Anything. I don't think I did anything wrong. I don't. Oh Lord. Please forgive me. This was supposed to be minus 1 and 4/5 B. I wrote the wrong question. Alright? I'm going to quickly do back BC. I'm going to quickly do back BC. Don't worry. 1 minute. We're going to clear this up. 1 minute. BC. From B to O and then O to C. B to O. 6A minus 3B. OC is 5 and 1/5 A minus 1 and 4/5 B. Right? I just adding the 1 here. Let's add this quickly. Hold on, I have to change the signs. B to O. Make this negative and make that positive, because I'm going against the arrow. So, when I add up these two, I'm going to get minus 4/5 A, right? Minus 6A plus that. And now, 3B minus 1 and 4/5 is 1 and 1/5 B, right? Remember, I don't like mixed fractions, so 1 by 5 is 5 plus 1 is 6. So you get 6 on 5. So just, that's the only change here. You're going to get 6 on 5. Alright. We're back to where we started. Where I made a mistake. So, minus 4/5 A plus 6 on 5B. Right. Remember, we had factorized AB, and now we're going to factorize BC. So I'm going to pull out minus 4/5, because when you don't know what to pull out, look at the first letter and whatever is touching it. So you're visiting him and dividing it by minus 4/5, and you're visiting him and dividing it by minus 4/5. These two cancel out, bam, bam, they give you 8. These two, well, a positive divided by a negative is a negative. Take the 6/5 and divide it by the 4/5. Remember, I already took care of the signs. The divide changes to a multiply, and you flip the 5 on 4. 5 and the 5 will cancel out to give you 6 on 4. 6 divided by 4 is minus, well, 1.5, and don't forget to put back the B. You notice that they look exactly the same in the brackets. But the only difference between this and parallel is this step here. You have to put down the 3 points, circle the first two, find it, then circle the second two, find it. And after you find it, factorize them. And then they will look exactly the same. And if they look exactly the same, then you have the right to say that they are collinear. A, B, and C are collinear points. Alright? So I hope this was helpful. I think this is the majority of things that will come for the CXC maths exam, not the additional maths exam. The additional mathematics examination has some extra formulas that we need to go through. Alright, so guys, my next video is mainly geared towards additional mathematics students. So once again, well, first of all, I want to apologize for the mistake. I'm really sorry about that. I read the paper wrong, and I hope that won't prevent you from subscribing, sharing, liking, and leaving comments. So guys, take care. Until next time.